Section 7-4, Nonlinear Functions. Think of a juggler's ball being tossed in the air and falling back down. The relationship between speed and time is not always the same. As the ball rises, the speed decreases. As the ball falls, the speed increases. The table shows the height of a juggling ball at a given time. You can plot the data from the table on a graph. So let's look at this table. We see we have the input in time, 0, 1, 2, 3, 4. You see it is changing by 1 every time. We're adding 1 each time. So the input is constant. But let's look at the output. To go from 3 to 5, we're increasing by 2. Then from 5 to 6, increasing by 1. Then from 6 to 5, we're needing to subtract 1. And then to go from 5 to 3, we're needing to subtract 2. So you see that the rate of change is not constant. The rate of change is not constant. So what I want us to do now is I am going to graph these points, okay? I'm going to graph these points. So we have the points, and I'll put them over to the side. We have the points 0, 3, 1, 5, 2, 6, 3, 5, and 4, 3. So they're all positive, they're all in the first quadrant. So this graph is going to represent the height of a juggling ball. Okay? So let's plot these points. All right, 0, 3. Remember, the first number's X, the second number's Y. So 0 up, 1, 2, 3. So right here. Now notice my vertical axis is representing the height. Every little marking is representing 1, 1, 2, 3, 4, so forth on. Always check that. Your horizontal axis is representing time, and every marking is representing a half. So see, I had 0, a marking, and 1. So dividing 1 by 2 means this represents a half. So this would be a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, so forth on. Okay? So from our chart previously, or from our table, we had input was our time, output was our height. Okay? So let's plot these points. 0, 3, over 1, up 5, 1, 2, 3, 4, 5. Okay? 2, 6, so to the right 2 on X, up 6, 1, 2, 3, 4, 5, 6. There's the point 2, 6, 3, 5. On the X-axis, 3, up 5, 1, 2, 3, 4, 5. And then we have the point 4, 3. On the X-axis, 4, up 3, 1, 2, 3. So you see our graph looks something like this. I'm going to connect these points, and here I have this graph, okay? So you see where I have graphed this now. All right, so I want us to read about this graph. Okay, here we have it. The rate of change is the change in the outputs divided by the change in the inputs. The rate of change was not constant. We saw it was not constant from our table. This side and this side have to be the same. In other words, all of these have to be 1 and all of these have to be the same number in order for the rate of change to be constant. Okay, so our rate of change we had already discovered is not constant. Okay, so the rate of change in this graph is not constant. In cases like these, non-linear, Nonlinear means it's not a line. You can see this is not a line. So nonlinear functions are needed to describe how the variables are related. So if you can take down the definition. Nonlinear functions are functions that do not have a constant rate of change. The graph of a nonlinear function is not a straight line. So this is a nonlinear function because it's not a straight line. It is still a function because the x's did not repeat, okay? So this is still a function, but it's just not a linear function.